Mr. Thiessen and Uncle Rico want to know who has the best chance of throwing a football over some mountains. And Mr. Thiessen and Uncle Rico must have good arms to be able to throw footballs over mountains. The table below shows the distances of 8 throws by Mr. Thiessen. The mean and mean absolute deviation are given for the distances of 8 throws by Uncle Rico. Complete the table and use the drop downs to compare Mr. Thiessen and Uncle Rico. All numbers are in meters. Round to the nearest meter. So they give us the mean distances of Uncle Rico's throws, and then the mean absolute deviation, MAD. And if you find this to be a strange term or is a little unfamiliar to you, we're going to calculate the mean absolute deviation for Mr. Thiessen, and then hopefully all of it will make sense. So first, let's figure out the mean distance of all of Mr. Thiessen's throws. And if we go to the original exercise here, so let's go to the original exercise here. You see that they do give us a calculator, so it is completely okay to use a calculator, but I'm going to do it on my scratch pad just so I can write a little bit easier. And so let's get the calculator out. And so all we need to do is add all of these 8 data points and then divide by 8. So 27 plus 28 plus 28 plus 30 plus 31 plus 34, 31 plus 34 plus 37 plus 37 plus 40. So that's the sum of my 8 data points is 8 throws in meters. And I'm going to divide that by 8 to get an average of 31.875. And so we can write that down. Now they want us to round to the nearest meter. So his mean distance, we could say, is 32. Just like that. Now they want us to figure out the mean absolute deviation. Well, it's just, since they told us to round, we could just continue to use this mean distance. It'll make the math a little bit simpler. And if we go to the original exercise, just to know what they want us to do. So we already know that this right over here is 32. On average, Mr. Thiessen's throws are longer than Uncle Rico's throws by 2 meters on average. But let's see what this dropdown says. About half the MAD, about 2 times the MAD, about 3 times the MAD. And I'm assuming they're talking about the MAD of Mr. Thiessen. So let's calculate Mr. Thiessen's MAD and see how 2 relates to that number right over there. Let me get my scratch pad out again. So mean absolute deviation. So the absolute deviation between each of these points is, well, how far is each of these points from this mean? And it's the absolute value because sometimes it's less, sometimes it's larger than the mean, but we just want to figure out how far it is, its distance. So we always want a positive value. So for example, the MAD, let me make a little column right over here. Actually, let me just write the absolute deviation, the add part of MAD, and then we'll mean them. The absolute deviation from 27 from 32, we could say it's the absolute value of 27 minus 32, which is the same thing as going to be the absolute value of 32 minus 27, which is equal to, well, this is a negative 5. Absolute value is positive 5. Here, absolute value of 28 minus 32, this is equal to 4. Absolute value of 28 minus 32, we just calculated that. That's equal to 4. Absolute value of 30 minus 32. Well, that's negative 2. Absolute value is 2. Notice, 30 is 2 away from 32. 28 is 4 away from 32. 27 is 5 away from 32. Now, 31 minus 32 is negative 1. What's the absolute value? It is 1. Notice 31 is 1 away from 32. You can even do that in your head. You can say, well, how far is this from 32? It's 5. How far is this from 32? It's 4. And so we could keep going. But I just want to show you that these are the absolute deviations. So 34 minus 32 is equal to 2. And then we have 37 minus 32 is equal to 5. And then the absolute value of 40 minus 32 is just equal to 8. And so now we just have to find the mean of these 8 numbers, the mean of these absolute deviations. So let's get our calculator back. And so it's going to be 5 plus 4 plus 4 plus 2 plus 1 plus 2 plus 5 plus 8. And let's just try to think about what this is. Each of these data points says how far is that throw from the mean. And now we're saying how, on average, how far are these throws from the mean. So we're trying to see on average, on kind of how much do his throws vary from that mean. So this is one way of measuring it. So these are my average deviations added up. And now I'm going to divide by 8 to get the mean average deviation. So 3.875, they wanted us to round up. So we could say this is 4. And so let's go back to the original exercise. So the original exercise, this right over here is 4. So on average, Mr. Thiessen's throws are longer than Uncle Rico's throws by, let's see, it's longer by 2 meters, which is about half of Mr. Thiessen's absolute deviation. So half of Mr. Thiessen's mean absolute deviation, I should say. We got it right.